If a quadrilateral is a square, then it is a rectangle. So it is again a conditional statement. If then means it's a conditional statement. Consider this as P and this as Q. In case of conjunction, true and true is true. In all cases it is false. So here conjunction of true and false is equal to false. T and F is F. What is this equal to? Very simple. This is equal to negation of P, disjunction, negation of negation Q. That's equal to negation P, disjunction, negation of negation is Q. Hello dear students, welcome to this session of basic mathematics class. I am Mr. Niranjan, faculty department of mathematics, Vidhyaashram PU College, the temple of excellence. So in my previous class we have discussed regarding the connectives in logic. So the logical connectives like conjunction, disjunction, conditional, biconditional and negation, and construction of the truth table for those connectives like truth table for conjunction, truth table for disjunction, truth table for conditional and biconditional and negation. So in this session I am going to discuss regarding the problems based on the connectives. Now here let us move on to the first type of problem. Symbolize the following proposition. So here the statement is given, the verbal statement is given. We have to put this verbal statement in a symbolic representation, symbolic form. Symbolize. So symbolize a given verbal statement. Let us recall what are the connectives we are going to use. And for and we are going to use P conjunction Q. And means conjunction. So or disjunction. Disjunction is nothing but PVQ. For disjunction we are using or. For conditional means if then can be written as P conditional to Q. If then, this is the conditional statement. If and only if and only if is nothing but biconditional statement. And the negation is nothing but not. Negation of any given statement is not P. These are the connectives. So conjunction, disjunction, conditional, biconditional and negation. So what are the connectives we are using? And, or, if, then, if and only if, and negation means not, N-O-T, not. Right. Using these connectives, just symbolize the following given compound proposition. Now first one, 2 plus 5 is equal to 6. Let us consider this as the equation P, 2 plus 5 is equal to 6. And the second statement, all integers are rationals. So let us consider Q as all integers are rationals. These are the two statements given. What is given here? What is the connective they have taken? R. R is nothing but what is R? R is the disjunction. We can write V. So therefore, the connective for this, the given statement is P disjunction Q. P disjunction Q means 2 plus 5 is equal to 6. Or all integers are rational. So that is P disjunction Q. That is P VQ is nothing but the disjunction. So the connective R is disjunction. So that is 2 plus 5 is equal to 6. Or all integers or rationals can be denoted as P disjunction Q. Now move on to the second one. So here very simple, R means we are going to use disjunction. Next, second statement, if two triangles are similar, then their corresponding sides are not proportional. Now here, what is the statement given here is if let us call this as P, that is two triangles are similar. Two triangles are similar, that is P. Then the second statement, their corresponding, what is given? Their corresponding sides are not proportional. So what is given here? Since this is not, they have taken the connection as negative. that is negation of Q. That is negation of Q is given, corresponding sides are not proportional. So, two triangles are similar, corresponding sides are not proportional means that is negation of Q is given. Now, it started with P and then P then means what is the connective we are going to use for P? If then is nothing but conditional statement. So, therefore, the given statement is P conditional to not is there negation of Q. So, therefore, the given statement is P conditional to negation Q. That's it. What is the meaning? That is, if two triangles are similar, then the corresponding sides are not proportional. So, the given statement is P conditional to negation Q. That's it. Okay. Now, move on to the next statement. If a quadrilateral is a square, then it is a rectangle. So, it is again a conditional statement. If then means it's a conditional statement. Consider this as P and this as Q. What is Q? It is a square. So, rectangle. Listen. Now, let us take P. Consider P as a quadrilateral. A quadrilateral is a square. A quadrilateral is a square. And what is the second statement? Q. Q. What is Q here? It is a rectangle. It is a rectangle. It is a rectangle. Now, if then is used. If then means it's a conditional statement. So, what is the answer? Therefore, the given statement is, the given answer for this is P conditional to Q. P conditional to Q. That means the given statement is, if a quadrilateral is a square, then it is a rectangle, means P is conditional to Q. So, for this, the required answer is P is conditional to Q. That is, if a quadrilateral is a square, then it is a rectangle. That's it. P condition. If then means definitely it is a conditional statement. Now, next, here 3x is equal to 9 and x is less than 7. Let us consider this P as 3x is equal to 9 and Q. What is Q? X is less than 7. What is the condition they have used here? Connective is an and is nothing but the conjunction. So, therefore, this can be written as P conjunction Q. That is P conjunction Q. P conjunction Q means 3x is equal to 9 and x is less than 7. So, the conjunction is the connective used in this statement. Hope you followed. Now, move on to the next problem. If the two numbers are equal, then their squares are not equal. If the two numbers are equal, it is. If two numbers are equal, then their squares are not equal. Here also, if this is P and then their squares are not equal means Q. Not equal means again it is a negation. So, P. What is P? If two numbers are equal. Two numbers are equal. This is P. And what is Q for Q? Squares are not equal. Their squares are not equal. That means they have taken the negation for this. So, therefore, the statement is P conditional to negation Q. That's it. So, P conditional to negation Q means if two numbers are equal and then their squares are not equal. This is how we are going to write the symbolic form for the given verbal statement. Now, let us move on to the next one. If oxygen is a gas, then gold is a compound. So, here also it is a conditional statement. If then is used, then this is P and Q. That means if oxygen is a gas, so here consider P. What is P? Oxygen is a gas. Oxygen is a gas. What is Q? Q is nothing but gold. Then gold is a compound. Gold is a compound. Now, these two are connected by if then means it's a conditional statement. So, P conditional to Q. So, here this is P conditional to Q. That's it. That means if oxygen is a gas, then gold is a compound. P conditional to Q. Right. Now, these are how we are going to write the symbolic representation for the given verbal statement. Now let us move on to the next type of problem. Second type, if the truth values of the propositions P, Q, R, T, T and S respectively, then the truth value for the compound proposition. Very simple. Just write down the truth value for the compound proposition. So here what is P? P is equal to true, and Q is also equal to true, and R is equal to false, right? So here just find out the truth value for Q conjunction R. Q conjunction R. Q conjunction, what is Q? Q is true conjunction false. So in case of a conjunction, true and true is true. In all cases it is false. So true and false is equal to false, right? So therefore this can be written as P. What is P? P is true. True conditional to Q conjunction to R is false. That's equal to true and false. In case of a conditional, true and false is false. So this is equal to false. So therefore this is equal to a false statement. This is equal to false. Okay. Otherwise, if you want, you can construct a truth table for this. So here what is given? P, Q, R, and then Q conjunction R, and then P conditional to Q conjunction R. So if you want, you can also write like this. So here what is given? P. What is P? P. The truth value for P is T. For Q it is true, and for R it is F. Now just write down the conjunction. Conjunction true and false is equal to false. Conjunction true and true is true. In all cases it is false. Now conditional statement, conditional for these two. For conditional, true and false is false. In all cases it is false. True. True and false is equal to false. So therefore the given statement P conditional to Q conjunction R is false. So you can do like this, or you can construct a table and do any method you can follow, right? 2 marks question, very simple, right? Now move on to the next problem. Same type. What is given here? We know the truth value for P, Q and R. For P it is true, for Q tree, for it is F. The truth values for P is T, for Q it is true, and for R it is F. That is already given. Now write the truth value for this. So that is what is given here. First write down P disjunction R. P disjunction R means what is P? True disjunction R. What is R? F. So in case of disjunction, false and false is false. In all cases it is true. So this is true, and false is equal to true itself. Now substitute here. So therefore this can be written as P disjunction R is true, conjunction what is Q? True. True and true is equal to true. So the given statement is true. So otherwise you can also check by writing the truth table, that is P, Q, R, P disjunction R, then P disjunction R, conjunction Q. Just write on the truth values. That's it. What are the truth values they have given? For P it is T, for Q also T, for R it is F. Now disjunction of P and R, true and false. True and false is true. True and false is true. True and false is true. And then the conjunction for these two. Conjunction for P disjunction R, conjunction Q. That is true and true is equal to true. So therefore P disjunction R, conjunction Q is true. This is true. This is how we are going to write the truth table. So this method or this method, any method you can follow to write the truth value for this given proposition. Now next, third one, P conjunction negation Q conditional to R. So here let me write in a table. What is this given? P, Q, R, then negation Q, then we have P conjunction negation Q, and again P conjunction negation Q conditional to R. So what is this equal to? Very simple. Split. First P, Q, R, P, Q, R, then negation of Q, then P conjunction negation Q, then P conjunction negation Q conditional to R, the entire statement. Now what is P? True. What is Q? True. R is F. They have given T, T and F. Now negation of Q is F. For true it is false. Now write down the conjunction for these two. P conjunction negation of Q. So true and false is conjunction true and false is equal to false. In case of conjunction, true and true is true. In all cases, it is false. So here, conjunction of true and false is equal to false. T and F is F. Now write down the conditional for these two. Conditional statement for these two. That is false and false. So what is the conditional statement for false and false? True and false is false. In all cases, it is true. False and false is also equal to true. So therefore, this is a truth value. So P conjunction negation Q conditional to R is true. Right. See here. Just write down the conjunction for P and negation Q. True and false is false. Conjunction is false. Again, the conditional statement. Conditional statement for false and false. False and false is equal to true. It is. Right. That's it. Hope you followed. Okay. Now move on to the next statement. P conditional to Q conditional to R. Same here. The truth values are P, Q, R. Write down Q conditional to R. Then P conditional to Q conditional to R. Okay. Now what are the truth values we have here? For P it is true. For Q also it is T. For R it is F they have given. Now Q conditional to R. Q and R, true and false is equal to false. In case of a conditional, true and false is false. Now, the conditional for P and this. Again, the conditional for P conditional to Q conditional to R, true and false is again a false statement. This is equal to false. That's it. See, Q conditional to R means Q and R, true and false is equal to false. Again, P conditional to Q conditional to R, true and false is again a false statement. Now move on to the next type of problem. What is given? If negation of P disjunction Q conjunction negation R is a false, then find the truth values of P, Q and R. This is an important problem for 2 marks. So what is given here? So negation of P disjunction Q conjunction negation R is false. This is false. Then what is the truth values for P, Q and R. Okay. Now listen. Here this is conjunction. First conjunction. Conjunction is false means it should be false and false is equal to false. So this implies this statement is false. Conjunction false. That means negation of P disjunction Q is equal to false. And negation of R is equal to false means therefore R is equal to true you will get. Right. See, conjunction is false means true, false and false is false. Right. So here negation of P disjunction Q is false and negation of R is equal to F means therefore R is equal to T. Okay. Now further, negation of P disjunction Q is false means, so in case of disjunction, false and false is false. In all cases it is true. That means this is false and false is equal to false. That means negation of P is equal to F and Q is also equal to F. So negation of P is equal to F means therefore P is equal to true. So therefore the truth values are P is equal to T, Q is equal to F and R is equal to T. That's all. These are the truth values. So truth values of PQ are true, false and true. That's it. Okay. See, very simple concept, very simple logic here. See what is given? Negation of P disjunction Q conjunction negation R is false. So conjunction is false means false and false. Yes, conjunction is false means if it is false and false. So false and false is false. That means negation of P disjunction Q is false, or negation of R is false means negation of R is false means, so then R is equal to negation of F is T. So R is equal to T we will get. The truth value for R is T. So here the first case, negation of P disjunction Q is false means disjunction is false and false is false. In all other cases it is true. So negation of P is false and Q is equal to false. So Q is equal to false we already get. Negation of P is false means then the negation of negation is P is equal to true. That's it. So therefore P is true, Q is false and R is equal to T. This is how we are going to find the truth values for given statement. Right. Okay. Hope you followed. Let us move on to the next set of problems. Negate the following propositions. what is given? P conditional to Q conjunction R. So we have to negate the given statements. So given propositions, right? Now let us take this problem. What is given? P conditional to Q conjunction or negation of this. So this is equal to negation of P conditional to Q conjunction R. So using this property, since negation of P conditional to Q is equal to, so using the property negation of P conditional to Q is equal to P conjunction negation Q. So use this property. Negation of P conditional to Q conjunction is nothing but this is equal to P then conjunction negation of Q conjunction R. So using the property negation of P conditional to Q is P conjunction negation Q. So here this is P and Q. So negation of P conditional to Q conjunction R is P conjunction negation of Q conjunction R, right? Okay. Now just use De Morgan's law. Using De Morgan's law, if you use De Morgan's law, this is equal to P conjunction negation of Q conjunction R can be written as negation of Q disjunction negation of R. That's it. So using De Morgan's law, negation of Q conjunction R can be written as negation of Q disjunction R. This is the negation for P conditional to Q conjunction R. That's it. Okay. So therefore, what is the negation? So therefore, the negation of P conditional to Q conjunction R is equal to what we got? P conjunction negation of Q disjunction negation R. That's it. Very simple. Just using the law, we know negation of P conditional to Q is equal to P conjunction negation Q. So P negation of this is P conjunction negation of Q conjunction R. Using De Morgan's law, what is De Morgan's law? So that is, this is as it is, negation of Q conjunction R is equal to negation of Q disjunction R. So therefore P conjunction negation Q disjunction R is the negation for the given statement. Now move on to the next problem. P conjunction negation Q. So we have to write the negation for this. Now just write down the negation. So the negation of P disjunction negation Q. What is this equal to? Very simple. This is equal to negation of P disjunction negation of negation Q. That's equal to negation P disjunction negation of negation is Q. Negation of negation is Q. So negation P disjunction Q. Since we know that since negation of negation Q is equal to Q itself. So therefore this can be written as negation of P disjunction, that is conjunction Q. So negation of P conjunction Q is the simplified answer. The negation of P disjunction negation Q is equal to negation of P conjunction Q. That's it. Okay. Right. Now move on to the next problem. Negation of P conditional to Q. Right. Now, so the negation of this, negation P conditional to Q. So this can be written as negation of negation P conjunction negation Q. So negation P conditional to is conjunction negation Q, right? So negation of negation P conjunction negation Q is nothing but, so this can be written as negation of P conjunction to negation to Q. So negation of negation P conditional to Q is nothing but negation of P conjunction negation Q. That's it. This is how we are going to solve this problem. Let's move on to the next type problem. So negate the following. So here the verbal statement is given. 4 is an even integer or 7 is a prime number. So we have to negate this statement. So negate 4 is an even integer or 7 is a prime number. 7 is a prime number. Now this is P. 4 is an even number or 7 is a prime number. Here P is nothing but an even number, R is nothing but what is given? P disjunction Q is given. Now write down the negation. Negation of P disjunction Q. Negation of P disjunction Q is equal to, so this is nothing but negation of P conjunction negation Q. That's all. Okay. Now how to write the statement? So therefore we can write, so negation of P means 4 is not even integer, and conjunction means and 7 is not a prime number, that's it. This is how we are going to write the negation. 2 more. See, very simple. So what is given? P disjunction Q is given. Negation of P disjunction Q is negation of P conjunction to negation Q. That is 4 is not even integer and 7 is not a prime number. Okay. Now move on to the next similar type problem. What is given? If two triangles are similar, then their areas are equal. So if two triangles, this is P, two triangles are similar, then their areas are equal. This is Q. So given P conditional to Q. Negation of P conditional to Q. Just write down the condition is negation of P conditional to Q. So what is this equal to? This is equal to P conjunction negation Q. That's all. P conjunction negation Q. Let me put it in the form. So negation of P conditional to Q is negation P conjunction to, yes, P conjunction negation Q means P. What is P? Two triangles. Two triangles are similar. Two triangles are similar and their areas are not equal. Areas are not equal. That's it. So two triangles are similar and their areas are not equal. That is P conjunction negation Q is the negation for the given statement. That's it. Hope you followed. Okay. This is how we are going to write the negation for the given statement. So, right. So, hope you followed. So, that's all regarding today's session. Let us meet with a different concept in the next session. Thank you. Thank you very much.